All right, guys, here we go. I hope you are happy. I hope that you are well rested from the 4 day weekend that you guys had. It's going to be nice and cold tomorrow. I hope to see everyone here tomorrow as we tackle math life. All right, here you go. You guys ready? So, area and calculating average value. So, we kind of already been doing all this area stuff. Real quick, just in case you forgot, which you didn't. Um, let's see. What am I going to say? Distance. Distance traveled is equal to the integral from A to B of what? Absolute value of? Yay! So that's distance. If I take away the absolute value, it is called a what? Displacement. So displacement is the integral from A to B of V of t dt. Let the units help you out. If velocity is in meters per second and time is in seconds, so yeah, area under the curve will be meters. Meters per second times seconds is just meters. Cool or not cool? Uh, an energy drink. All right, here we go. Here we go. From physics, I actually accidentally put an extra P there. I don't know how I did that, but from physics, I'll delete that later on. From physics, average velocity is equal to displacement divided by the change in time. Sometimes they call this like x of f minus x of I divided by the change in time because the change in position is displacement, right? So it just depends. It depends. Okay, that's what you did in physics. Are we okay so far? In calculus, average velocity is equal to, well, displacement. Look, here's my symbol of how to do that. Displacement is just the integral from A to B of V of t dt. And I'm dividing by the change in time. So if A is my lower time and B is my upper time, the change in time must be B minus A. Isn't that cool? All right, check this out, guys. Let's write it nice and pretty. Chub, it looks pretty already. Well, yeah, but let's make it look super nice. I can write it like this, and now look how beautiful it looks. That's the same. They're the same, guys. What do you guys think? Nothing crazy, right? And there it is. This is what we're going to be using for average everything. Okay, now what if we want average f? Okay, let's think about it, guys. Let's use our hack. Average of f is equal to, look, remember, that box that we just wrote is average velocity. So take a guess. How do you think the formula is going to look for average of f? Notice, look, velocity is here. Oh, look, average velocity. So what if I want average of f? Like, what's my formula if I want to know the average of f? 1 over b minus a to b of f of t, f of x. Remember, it's just a dummy variable. It doesn't matter. Yay, look, there it is, guys. You got it. This is a formula we're going to use all the time for average. And guys, I don't want you to be a robot, so let me explain what it means of what it means to be an average. So let's do, I'm going to do, what am I going to do? All right. Okay, linear line. These are just examples. And let's do this. It's just a linear line. I'm going to call this, what do I call that? Y equals x. Here's 0. And what's your favorite number? 4? 3? Okay, 8. Cool or not cool? What is your average? Okay, look, guys, I'm just trying to make sure that we know that this formula works. That's an 8 because it's y equals x. Y equals x. What is your average value for y equals x between 0 and 8? Use your intuition. No calculus. Yeah, look, use your intuition. I started at 0, 0, 0. It's just a linear line. And I end at 8. And remember, x equals y or y equals x. So what is the average value? What's your average y value between 0 and 8? 4, right? Do you guys agree with your intuition? What's up, Silali? Tell me. Okay, so check this out. Using the formula, let's see if we get 4. So it says, this tells me that I got to do 1 over 8 minus 0, integral from 0 to 8, and then that's y equals x. So I'm going to write x dx. We don't have to do that, of course. We could just use geometry, but I'm using the formula so you guys can see that it works. So this is just 1/8, and then bracket. I'm just doing the antiderivative of x. That's x squared over 2 from 0 to 8. Are we still okay? If you're wondering what I'm doing, I'm using the formula. I want to see if the formula is going to give me that 4 that we did with intuition. I see a 2 in the bottom. Both terms are going to have it. I'm just going to take that out. 1/16 x squared from 0 to 8. So this is 1/16 bracket. I'm going to do upper minus lower. I don't care about the 0 because 0 squared is 0. So 8 squared. OMG. Okay, so I have 1/16 times 64. Does 16 go into 64 4 times? Or I guess I can just go 64 over 16. 16, 32, 64. Yep, 4 times. I got the average value of 4. Do you guys see that? Okay. I don't want us to be robots, guys. Let me explain what's happening. Look at, okay. What's the easiest way for you guys? Okay. Here's what I'm thinking. That's the easiest. Why did I what? Upper minus lower. My upper limit was 8. So I put 8. I just did upper minus lower. 8 squared minus 0 squared. That's what integral means, miss. F prime of x dx, a to b, f of b minus f of a. So I did the antiderivative of x squared over 2. And then I just did upper minus lower. F of 8 minus f of 0. Help me help you. Help me help you. Tell me. You don't get what? This? Why did we do the upper limit? That's fundamental theorem of calculus. That's how, when we do the antiderivative of this, it's upper minus lower. Antiderivative of x is x squared over 2. I factored out the 2. No, I just did this so we can, okay, the whole, see, this is why I was tempted to not even do it. I just did this to prove that my average value was in fact 4 that we did with intuition. You know what I mean? And now I was about to explain, we're going to give an easier example. What's up, Salali? Okay, check it out, guys. So maybe this will help you. So let me finish this right here. All right, guys, so let me start off with an easier example. So remember how I told you that the average value between 0 and 8 for this y equals x was 4? And you did that with intuition. It's just a linear line, right, with the slope of 1. All right, so the area under here from 0 to 8 would have been the same if I would have had a flat line right at 4 all the way from 0 all the way to 8. So this area here, see how the y value is always 4? So look, with intuition, there's no intuition for that one. The average value for that one is always 4. You're always 4. The y value is always 4 all the way between x equals 0 to x equals 8. So the average value for this one right here that I just drew with the scale in black, or the x-axis and y-axis in black, the average value is always 4. Yes or no? Check it out. If I were to check it out, Ms. Konduru, this area under this curve, 8 times 4 is, what's that? 32. Check it out. This area under this curve is also 32. Chop, I don't know what you're talking about. Look, I'm just doing area under the curve from 0 to 8 of x. Right? Well, what does this mean? It means to take my antiderivative. This means area under that curve. Remember, look, I got the area of 32, right? Look, antiderivative of this is x squared over 2. Evaluate this from 0 to 8. Okay, upper minus lower. So 8 squared over 2 minus 0 squared over 2. OMG, 64 divided by 2. What do I get? 32. So this area here is the same as this area here. So, cool or not cool? Notice this rectangle has an average value of 4. OMG, between 0 and 8, this line here has an average value of 4. How do you find the average value? Notice that 32, that's just area under the curve. How do you find the average value? Area under the curve divided by your interval. 1 over 8 minus 0, integral of your f of x. That's how you find average value. Look, here it is right here. What do you guys think? I know it was like amazing. Cool, right? Does that make sense? Lopez, what do you think? Pina, does that make sense?
Yes.
All right, Kanduru, are you a little better
At what?
at average?
Just better. Yeah.
All right, check it out, Kanduru. You're going to give me this answer, and I bet you're going to get it right. Use your intuition. So find the average value of the function x cubed on the interval -2 to 2. Does everyone know how x cubed looks like? You don't know how x cubed looks like? Yeah. So check it out. Check it out. It looks like this.
Oh, okay, we're on to something.
Yeah, we're onto something. Let me erase this arrowhead because, yeah, no big deal. I can draw it again. All right, here's -2. Here's 2. Use your intuition. What's the average value between -2 and 2 of x cubed? Yeah, how'd you do that so fast? It was okay. I like where this is going. Kunduru told me this, not in very short words. She told me, well, it's because this area here is equivalent to the area above the x-axis, and they cancel each other out. Do you guys see that? So that's why, and you can already see, look, it's symmetric about the origin. So you can already see that the average value is going to be 0. You can see that. Cool or not cool? If you were to try to do, you don't have to follow this. I just want you guys to observe. If you were to try this, 2 minus -2 chop, what are you doing? I'm using my formula. From -2 to 2 of x cubed dx, you will definitely 100% get 0. So check it out. I get a 1/4 right here. Bracket, antiderivative of x cubed is x to the 4 over 4. Right, Kanduru? And then look at lower limit -2, upper limit 2. And then, guys, so start being really good with algebra. You can, if you want, leave that 4. Child, there's so many 4s all over the place. What 4 are you talking about? I'm talking about this one right here. You can, if you want, leave that 4 in there. But think about it. You're going to do upper minus lower. Both terms are going to have that 4 in the bottom. Yes or no? Think about it. You're going to do upper minus lower. That's how you evaluate antiderivative. And both terms are going to have that 4 in the bottom. Make life easier for yourself. Factor that 4 out.
What do you mean both?
Yeah.
Just the one on the outside and the inside?
Don't, when I do this, remember I do f of b minus f of a? I got to go 2 to the 4th power divided by 4 minus -2 to the 4th power divided by 4. But both of the terms have a 4, so just take the 4 out to make life easier. So hopefully you guys are getting better at how to mimic some of this stuff. So look, life is easier now. Look, it's easier. So now all I got to do is just evaluate x to the 4th, upper minus lower. So here it is. I like red. Red's my favorite color when it comes to writing notes. 2 to the 4th power minus -2 to the 4th power. OMG, 1/16. If you want to see what this is, in case you don't see that that's 0, 2 to the 4th power. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 minus, notice that's a negative, but I'm raising it to the 4th power, so it's going to turn to a positive. -2 times -2 is 4. 4 times -2 is -8. -8 times -2 is 16. So, see? 1/16 times 0. OMG, I got 0. They also asked another question. And determine the number c on this interval for which f of c is equal to the average value. All that means is set your function equal to 0. I know, it's silly. Where do you reach? So what is it trying to say? When does this function reach its average value? Well, at the origin, because it's going right through the y value of 0. So maybe that part's not necessarily fun, but we answered the question. Don't worry, guys. We're going to practice. We're going to practice a whole bunch. Look at this. Oh, you need your calculators, guys. Do you guys have your calculators? It says, an observer measures the outside temperature every hour from noon until midnight, recording the temperatures in the following table. So there it is. Use trapezoidal to help you out. What was the average temperature for the 12-hour period? All right. Let's go ahead and first write out the formula for how we're going to get this average value. So here's the formula. Between noon and midnight, how many hours is that? Yeah, 12. So 1 over 12 minus 0, or I guess you can just say 1 over 12, integral from noon. So I'm going to call that the 0 hour, all the way to midnight. That's the 12th hour of temp. My temp. You got to put DT. Make sure to put DT. Some of you guys in the activity didn't put your DT. Depending on the question, that might hurt you. You might lose a point if you don't put that DT. Because remember, this means area under the curve. I'm going to be focused on this right here. And in a little bit, we'll go ahead and do the divide by 12. You guys ready? So I'm just finding, they told me to use what tool did they want me to use? Trapezoids. They all have, okay. Sorry guys, I'm getting hyped. They all have a delta x of 1, which is like your height of the trapezoid, because the trapezoid's on the side. Does that make sense? Because they all have a height of 1, I'm just going to use my little formula. So here it is. I'm just doing this in black. So I'm going to write 1 over 2, giant parenthesis, 63 plus 2 times 65 plus 2 times 66 plus 2 times 68 plus ... keep going, 2 times 58 plus 55, close. That's just that in black. Close parenthesis. There we go. Now I got it. All right, I'm going to take my calculator. You guys can probably do it faster than I can. Well, I haven't even taken out the calculator here yet. All right, what was it, guys? I have a 0.5 on the outside, open parenthesis. What's the first one? 63 plus 2 times... You guys okay? 65, yeah. 2 times 65 plus 2 times 66 plus 2 times 68 plus 2 times 70. Don't sound depressed. Plus 2 times 69 plus 2 times 68. There you go. Now we're sounding happier. Plus 2 times
68.
Again?
Yeah.
Yeah. Plus 2 times
65.
plus 2 times.
64.
Oh, you guys sound so happy. 2 times.
What? 62.
62. Plus 2 times.
58. And then the last one plus 55. No 2.
Plus 55.
No 2.
Close.
No 2.
782. Is that what you guys got?
Yeah.
Okay, so here's what I have now. 112. Chop, that's not the answer. That's not an average temperature. Of course not. You have to divide that by 12. Yeah, you're in a good mood. Yeah, every day is a good day to do math. Doesn't doing math make you guys super happy?
Yes, it's the highlight of my day every day, sir. I look forward to calculus.
Oh, that makes me so happy. Thank you, miss.
Of course, sir.
There it is. There's your average temperature. All right. Let me give you guys, not necessarily a warning, but it happens every year. There's always at least one. Maybe this will be the year that it doesn't happen. And if it doesn't happen, maybe I'll give you guys extra points. I always ask either some question like this or something dealing with something, and you're going to tell me, so this is my average temperature, 65.1666667. It is perfectly fine. It is within the bounds. If you get a number like 42 degrees Fahrenheit is the average temperature. Guys, 42 is never even part of that. But there's always someone that does it. Or you tell me, you tell me 74 degrees is your average temperature. Guys, I never even got warmer than 70. How can 74 degrees be your average temperature? Do you guys see what I'm trying to say? So this is how you know some of you guys are robots, because you guys just, whatever number you get, you just put it in there. Guys, look at the question, look at it, and make sure that it doesn't. Okay. All right. Let's see. Do we have any questions right now, guys? Are we understanding? Do we understand like the whole logic behind all this stuff? Okay. Hopefully all these little proofs helped out. All right. Check it out, guys. This is from the 2016 international exam. I can't remember what exam we just took during mock exam 1. Was it 2017? Dang. Yeah, you're right. We took 2017. I should have done a poll on this one. I didn't. I'm sorry. Take 2 minutes. Look at the percentages of the students that got this question correct. But remember, they had the whole year. We're just starting out. Take 2 minutes. See if you can figure out this question and get it right. No calculator. Try it out, guys. Maybe you will identify.
Oh, yeah, sure.
Yeah?
Oh, yeah, sure.
Okay. In a little bit.
I don't know if I'm going to explain it right, but.
Okay, you will guide me.
Yeah.
You're like,
I'll take it. I'll write it out.
No, as long as I open the bag.
give it a shot. Give it a shot. Give it a shot, guys. Give it a shot. You got an answer, Kunduru?
No.
Man, why are you doing that?
I have an answer for a lot of questions, just not this one.
Oh. Okay, low key.
Not yet.
Let's answer.
Look, you're
Oh.
trying to.
Okay, high key. Let's go ahead and.
Let me log in. Let's try Keelan's distracting.
LMC. Come on, focus.
Guess what? I did this already.
Oh, okay.
Yeah.
All right, if you're close to getting it right, keep going. I'm gonna start telling Pina for giving me directions. All right, Pina, what's my first move?
So we gotta set up the equation, right? So average F.
Okay, average
Average
of F.
And then we have to find the interval. So 1 over 6 minus 4.
1 over 6 minus 4.
And it's between.
So,
integral 4 to 6,
from 4 to 6.
1 over x dx. And then.
If you did that, that's half the battle. 1 over 6 minus 4, that is just 1/2. Are we still okay? All right. What's the antiderivative of 1 over x? ln of x. My lower limit is a 4. My upper limit is a 6. You're going to do upper minus lower. So here it is, 1/2. That is that 1/2. Since I put the equal sign, make sure that you put that 1/2 there like that. Bracket, I'm doing upper minus lower. ln of 6 minus ln of 4. Chav, I don't see that answer in there. Properties of logs, I'll write it over here. Side note. ln of A minus ln of B, as long as B is not a 0, is ln of A over B. That's a side note there. So here we go. 1/2 bracket 1 ln 6 over 4. Chav, I don't see that answer in there. 6 over 4 reduces 1/2 ln of 3 over 2. Do you guys see that? How do we feel, guys? Okay. This morning, first period wanted me to do example 4. I accidentally put this in here. We have not done something called U-sub. I will let you guys know. I'll give you guys the same option. Do you guys want me to do this question even though we haven't done U-sub so you can see what's coming? That's what we're going to do next. I just forgot that I put this one in here. You guys want to see it? Or no? Wait, do it? Okay. All right, guys. So it says, what is the average? So if you can do the setup, you're winning. 1 over pi over 2 minus 0 integral 0 to pi over 2 sine x cosine x. All right. Here's one of the strategies on how to do this. It's called U sub. We only do this when it's a definite integral and we're not going back to our x. That's also true in life. They're your x for a reason. Do not go back to them. So that's what we're going to do here. No. Look, for us, real talk. This is real talk, guys. If there were no definite integrals, if it was not a definite integral, then it was never about us. It was never about you. Then maybe go back to your x. But if you have definite integrals, yeah. Look, you have limits. You're defined. You defined your relationship. You're not going to go back to your ex. You're going to work with you. We'll talk about it tomorrow. You'll see. So here it is. 1 over pi over 2 integral. And here's what I'm going to do on the side, guys. If u is sine x, then du, I'm taking the derivative of u with respect to x, is equal to cosine x. Do you guys see that? Now check it out. I'm going to multiply this by dx. So whatever you do to one side, do to the other. So you have du equals cosine x dx. So I'm going to substitute. And this is, I'm getting ahead of myself here, guys, but this is what we're going to do tomorrow. See that cosine x dx? That's just du now. And then sine x is just what? U. So I'm going to write u du. And now we're going to say when, no, because now we have a new letter. Now we're going to say when x is 0, sine of 0 is still 0. So that one stays the same. But when x is pi over 2, Chav, where are you plugging this in? Right here to sine x. So that's what u is. Sine of pi over 2 is 1. So I'll put a 1 on the top. See? So now here's what you got. This right here, 1 over pi over 2, that just means reciprocal, right? So that just means 2 over pi. I'm going to put this in brackets because I'm doing the antiderivative of this. U squared over 2, evaluated from 0 to 1. You can take that 2 out if you want, but we can just leave it because the 0 we don't care about. So 2 over pi, upper minus lower, but when you plug in 0 squared, it's just 0. So if I plug in a 1, what's 1 squared? 1, and then I'm dividing by 2, so this is going to be times 1/2. Do you guys see what I did? And then the 2's cancel out. And then your answer is just simply 1 over pi. Kind of cool. Relax. If you got a headache with that, don't worry. We're going to do a whole bunch of them tomorrow with U sub. If we're ready. Well, I'll figure it out if we're ready or not. All right, here we go. Example 5. Suppose that b is greater than 0 and that the average value of 5x minus 3 on 0 to b is 1/4. Find the value of b. Guys, this is more of an algebra problem than calculus. There's a little bit of calculus, but it's not much. First, do your average value formula. Because look, they tell you that's the average value. So do the average value formula. 1 over, what's my interval? Yeah, 0 to b. So I'm going to write b minus 0. Does everyone see where I got that? Integral from 0 to b of 5x minus 3, close it, dx equals 1/4. You don't have to put parentheses if you don't want to. It's understood that the dx marks the end. All right, so the only calculus is the middle part right here. So 1 over b, and I'm going to put bracket, because in that bracket I'm going to put my antiderivative. What's the antiderivative of 5x? 5x squared over 2 minus, what's the antiderivative of 3? 3x. Close it. 0 to b equals 1/4. I'm going to do upper minus lower. So here it is. I'm going to go slow, guys. 1 over b, giant bracket, big parenthesis. I'm going to do the upper first. 5b squared over 2 minus 3b, close parenthesis. And I guess you don't have to do the 0 one, but I'm going to do it just to make sure that you guys understand I'm doing upper minus lower. 5 times 0 squared over 2 minus 3 times 0, close parenthesis, close bracket. All that still equals 1/4. This that I'm circling in blue, guys, is just 0. You didn't have to do that if you saw it. All right, here's what I have. 1 over b, giant parenthesis, 5b squared over 2 minus 3b, close, equals 1/4. I'm going to distribute. I'm going to distribute this. What's up, Kanduru? Ask me. You okay? Okay. When I distribute this, guys, that b squared goes away, and I have this. Look, it's just an algebra problem. 5b over 2 minus 3 equals 1/4. See, when I distribute the 1 over b to the 3b, the b's cancel out. Do you guys see that? All right, next, move the 3 to the other side. Look, it's just algebra. 5b over 2 equals 3 times 4, 12, 13. 13 over 4. Chubb, I don't like that. Okay, 3, 1/4. 3 times 4 is 12. This is 13 over 4, but if you don't like that, you can have done this. 3 plus 1/4, guys. 3, multiply that by 4, so that's 12 over 4 plus 1/4. So that's your 13 over 4 if you don't like that. Okay, here we go. I want to get b by itself. Multiply by the reciprocal. So multiply by 2/5. Multiply on the right-hand side by 2/5. So finally, I'm going to move it over here. B equals, let's see, the 2 goes into 4 twice, and 2 times 5 is 10. 13 over 10. And there it is. I just did algebra, Kanduru. Okay, where? From this one, I went to here, and then from that one, I went to just get my b by itself. Because I was running out of space. I was running out of real estate. And this on the side is just gibberish, because some of you guys didn't like the 3 1/4. All right. Here we go. All right. Here we go, guys. We're almost done. The region A, B, C, and D in the figure below are bounded by the graph of the function f and the x-axis. The area of region A is 4, so I'm going to put 4. The area of region B is 11, so I'm going to put 11. The area of region C is 19, so I'm going to put 19. And the area of region D is 13, so I'm going to put 13. What is the average value of f on the interval -5 to 7? Okay, guys, you're just doing the formula. 1 over 7 minus a -5 integral from -5 to 7 of f of x dx. See? That's how you're doing, guys. So 7, 8, 9, 10, 11, 12. So this is 1/12. Let me know if I'm adding wrong, because sometimes I add wrong. 7, 8, 9, 10, 11, 12. Yep, we're good. All right, here we go. Am I going too fast? Okay, let me slow down. Guys, integral from -5 to 7 just means area under the curve, signed area. We're talking about signed area. Here's -5, my start, and here's 7, my end. So I'm going to go 11 plus a -19 plus 13. Does everyone know why I've made the 19 negative? Okay, that's what? Yeah. It's under the x-axis, so when I integrate, that's a -19. All right, here we go, guys. I'm going to add them up. The difference between 11 and 19 is 8, but the 19 was negative, so that's -8. And the difference between 8 and 13 is 8, 9, 10, 11, 12. Yes, 5. So positive 5. So 1/12 times 5. I think that's correct. Multiply them. So 5 over 12 is the average value. Does that make sense, guys? All right. Here we go. Try to do. I know that you can do this with a calculator really fast, but remember, guys, you're probably not going to have a calculator. 60% of the exam is no calculator. So let's try to do it without a calculator. Let f be the function defined by -2x squared minus 3. What is the average value of f on the interval -1 to 1? All right, here we go. Okay, there is a hack, but I'm not going to bother doing it. Here we go, guys. I'm going to go 1 over 1 minus a -1. Integral -1 to 1 of -2x squared minus 3 dx. If you can do that, you have a chance. No, guys, it's because maybe you just Maybe we just haven't practiced enough. I think you can get it right. I think you guys are smart. So I have 1/2. That 1/2 is this guy. Here's my bracket for the antiderivative of the inside. So negative 2x to the third power divided by 3 minus, what's the antiderivative of 3? 3x. From -1 to 1. There is a hack in here. Maybe we'll try the hack afterwards, but only if you see it. All right, here we go. Upper minus lower. 1/2. That's half is that one. Big bracket. I'm going to do the upper one first. So parenthesis. -2 parenthesis 1 to the third power over 3 minus 3 times 1. Close minus open parenthesis. -2 parenthesis -1 to the third power over 3 minus 3 times -1. Close bracket. Okay, I think we got it. I think. Let's see. I'll do it over here. 1/2 bracket. This is going to stay negative. -2/3 minus 3. Minus, and then negative times the negative is a positive. So this is going to turn into a positive 2/3 plus 3. All right. Let's see. I'm going to distribute this negative here, guys. So that's going to turn into a minus. And that's going to turn into a negative. Do you guys see that? So let me see if I can do this and still be organized here. 1/2 bracket. I see 2 2/3. 2 negative 2/3. So that's going to be a negative 4/3. There it is. And I see 2 negative 3s. Do you guys see that? So minus 6. Are we cool so far? Okay. Let's see. I'm going to turn that 6. 6 times 3 is 18. So I'm going to turn that 6 into 18 over 3. 18 over 3. Why'd you do that, Chav? So I can subtract it with the -4. So here's what I have. 1/2 bracket 18. 19, 20, 1, 2. Negative 22 over 3. Is that correct to you guys? And then that 2 goes into 22 11 times. So here's my answer. Negative 11 over 3. And no, that's a demerit. Sorry, miss. I'm not going to give you a demerit. All right, let's check to see if the calculator would have done. Yeah, I know. This would have been a lot easier. Look, 11 over 3 is what? I know that it's a negative. So let's see if I would have gotten that. You don't have, just observe, guys. So what do I have? 1 over 2 in the bottom. And then it was math 9, -1 to 1. And what was the function? Negative 2x squared. Was it -3? And then check it out, guys. Look, Enduro. Bam. We would have gotten it right. This was a lot faster, too. Well, it's supposed to be negative. I just didn't put a negative on mine, but it's supposed to be negative. Look. All right. We got it, guys. Okay. Don't worry, guys. We're going to be done pretty quickly. This next section, I don't think you guys will have any issues. We're just going to do 3 problems. I think we can handle it. That's why. All right. I think we're good. Can we keep going or no? Okay. Check it out, guys. I have a grid. Don't worry. You guys are not going to suffer. I have a grid. I have a graph. I'm going to call it f of x. And I have a graph below it. And I'm going to call that g of x. I'm going to say, what am I going to say? I'm going to say here's A and here's B. And I'm going to draw this. I'm going to go integral from A to B of f of x dx. That will give us all this. That will give us all this in red. So I'll color code it. And I'm going to go minus, and then in green, I'm going to go integral from A to B of g of x dx. That will give us all this in green. If I take the red area and I subtract the green area, I will get this in purple. The area between those two curves. Do you guys agree? Do you guys agree? So I'm going to equal this. And look, I could have just said That's going to give you the area between a and b of f of x minus g of x. And then put that in parentheses and put a dx. So you can always do that. You can always get 1 and subtract. You can always tell what's at the top and bottom. Draw a vertical line. That's in the top, that's in the bottom. So how do you do it? You do upper minus lower. And you're still adding an infinite amount of rectangles. That's what allows us to do that. Riemann sums. And there it is. What's up, Andrew? So we're good? How do we feel, guys? Nothing crazy, right? Okay. So check it out. Let's see. Is there anything that I should add to this? No, we're good. I think we're good. Guys. So let's just apply the definition. No calculator, relax. You'll be fine. It says find the area of the region between secant squared and sin x. So they want that. So what am I going to do? You could do it in 2 steps. Don't just do it in 1. Go integral from what to what? 0 to power 4. What curve is on top? Draw a vertical line if you don't know which one's on top. What curve's on top? So I'm going to write secant squared x. And then what curve's on the bottom? Sin x. And then I put a dx. Oh, that's what I forgot to say. Yes, some of you are probably looking at it like, Chav, you need your parentheses. Guys, it is understood that dx is the end of your integral. So it's all, if you want to be proper, put parentheses. But I'm letting you know, in case it irks some of you, like, oh, this irks me. Some textbooks will not put parentheses. And I know, because you're always used to, like, this is the height, Chav, this is the height, and the dx is the width. So I'm adding infinite amount of rectangles. So width times height, it should always be parentheses. The author the dx is known, like that's the end of the integrand. So sometimes you'll see it without a parentheses, and it's okay. Are we okay, guys? Or are we not okay? Do you guys want parentheses? No? Okay. Some of you said yes, some of you said no. Yeah. All right, here we go. What's antiderivative of secant squared? Is it secant or is it tan? It's tan. Yeah, the derivative of tan is secant squared, guys. The derivative of secant is secant x tan x. So there it is. What's the derivative? What's the antiderivative of sine? Cosine x. So the derivative of cosine is negative sine. Do you guys see that? It's a definite integral, so you're not going to put a plus c. I have more than one term, so I'm going to put that in bracket. Put a 0 in the bottom, put a power 4 on the top. Upper minus lower. Giant parenthesis. Tan of pi over 4 plus cosine of pi over 4. A little bit of pre-cal, baby pre-cal. Minus tan of 0 plus cosine of 0. Cosine of 0 is not 0. All right, here we go. What is tan of pi over 4? Tan is y divided by x. At pi over 4, both the coordinates are the same. That's a 1. Cosine of pi over 4. Square root of 2 over 2. Minus, so this is a 1 parenthesis. Tan of 0 is 0. That one is 0. Y divided by x. 0 divided by 1 is 0. Plus, what's cosine of 0? 1. Close parenthesis. Distribute the negative. So what's going to cancel out? The 1s cancel out. And what do I have? Square root of 2 over 2. There's your answer. That's the area between 0 and power 4 of the secant squared graph in sin x. Cool, right? Okay, don't worry. We just have 2 left. And then one's with a calculator. So this is the last one that we have to quote unquote suffer. And we're done. All right. Here we go. Yeah, I don't like to run lessons longer than 45 minutes. So sorry, guys. All right. Find the area of the region enclosed by the parabola. You can see here, they did this for a visual. You can see here that the x value, the leftmost x value is -1, and the rightmost value is 2. But what if we didn't have that picture? Here's how you would have done it. You would have set this equal to that, and you would have gotten your limits with algebra. You would have gone 2 minus x squared equals -x. And then you're like, okay, well, I'm going to move everything to the right. So 0 equals x squared minus x minus 2. That's how you find your x values. I need to find, we already know them. Obviously, it's -1 and +2. But if you didn't know them, this is what the steps that you would do. And then you factor out Yes, to find the intersections. X, X, and then 1 and 2. And Chav, how do I decide which one's which? Where do I put the plus? Where do I put the negative? Come on, Magia. We're so close. So I want to add up to a negative 1. Put the negative in front of the 2 because when you add them, you want the larger number to be negative. So there it is. So the only way this will equal 0 is if x equals negative 1 or if x equals 2. See? And then you're going to go integral from negative 1 to 2. Oh, Chop, now I got to decide which one's on top. Here's an easy way to do it, guys. See how we got the interval negative 1 to 2? Pick a number like 0, and then you can see which one's on top. If I put 0, this one I get 2, and this one I get 0. Chop, I don't know what you're talking about. Yeah, trying to decide which one's on top. You can see visually here that the parabola's on top, but if you needed to figure out, like let's say we didn't have this picture, you know what I mean? If we didn't have that picture, just pick a number between negative 1 and 2. If we pick 0, look, that y value is 2, and that y value is 0. Oh, this one must be on top, this one must be on the bottom. See? The bigger number is always on top. So here it is, parenthesis, 2 minus x squared, close it, minus a negative x, dx. Giant parenthesis like that, in case you don't like it. I am going to fix it, guys. So here is me fixing it. Integral from negative 1 to 2. You want to put the highest degree in the front. Negative x squared minus a negative. That's going to turn to a plus x. And then that 2 is by itself. Plus 2. There it is. Dx fixed. All right, here we go. Ready? Antiderivative of a negative x squared. X cubed over 3. Antiderivative of x. Not everyone at the same time. Yeah, x squared over 2. Antiderivative of 2. 2x. From negative 1 to 2. You guys ready for the algebra part? Yeah. Here's the algebra part. I'm going to put it way over here. Open parenthesis. Negative 2 to the third power is negative 8. So I'm going to write negative 8 over 3. Plus 2 squared is 4. 4 divided by 2 is 2. So plus 2. Plus 2 times 2 is 4. Close parenthesis. I don't see any mistakes. Minus, open parenthesis again. I'm doing the lower one. Negative 1 to the third power is a negative 1. But times the negative, it's going to turn to a positive, 1/3. And the negative 1 squared is going to be a half. Or it's going to be 1, but divided by 2 is a half. And then 2 times negative 1 is a negative 2. All right, here we go. Let's see. I'm trying to think what's the easiest route. I'm going to go ahead and multiply this guy by 2 over 2, this guy by 3 over 3. We're just doing arithmetic now, guys. So let's see. I see 2, 6 right here and 3, 6 right here. So I'm going to add those. And then I should have done it with it. Okay. I'm going to multiply this one by 2 over 2 to get a 6, to get a denominator to be a 6. So negative 16 over 6. Okay, I'm going to add up all those, but remember, there's a minus sign right here. So I'm going to add these and turn it into a negative. You guys see what I'm doing? Here we go. Negative 16 over 6 minus 3 plus 2 is 5. So minus 5, 6, because I distributed the negative. And then I see 4 plus 2 is 6. Minus 2 is 4. So plus 4. I hope I didn't do anything wrong. Nope, plus 2. There we go. Because that's a minus a negative there, right? 4 plus 2 is 6. Plus 2 is 8. So plus 8. Right now, we'll check it, guys. 16 plus 5, 16, 17, 18, 19, 20, 21. So negative 21 over 6 plus 8. Multiply the 8 by 6. What's 8 times 6? 8, 16, 40, 48. So 48 over 6. 48, 38, 28, 27. 27 over 6. Let's see if this is correct. What's up, Salali? I'm going to find out if this is right, guys. I know. Look, I'm just going to take a shortcut. You see how y1 is 2 minus x squared? I'm just going to go, let me reset everything. Look, I'm just going to go 2 minus x squared. That way I don't have to type a lot. And what was the other one? Negative x? That's on y2. Negative x. All right, here we go. Let's see if we got it right. Second quit. Math number 9. From what to what? Negative 1 to 2. And the parabola's on top, so I'm going to go alpha trace y1. And then the linear line's in the bottom. Alpha trace y2. And I'm going to put x. 4.5. Is that what we got? 27 over 6? Yeah, that's 4.5. 27 over 6. 4.5. Cool, right? All right, last one. And guys, relax. I know everyone's tired. This is with a calculator. So everyone follow along because you're going to need the skills. Do you guys have your calculator? Okay, this is the last one. Find the area of the region enclosed by the graph of y equals 2 cosine x and y equals x squared minus 1. Can you tell which graph is what? X squared minus 1 is the bottom one. Look, if you plug a 0, you get 2 for cosine, which is this up here. So this top one is y equals 2 cosine x. And this bottom one is y equals x squared minus 1. Put the 2 cosine x into y1. Put the x squared minus 1 into y2. So I'm going to take my calculator. Y equals, I already forgot. What did you say? 2 cosine x? And x squared minus 1, right? X squared minus 1. All right, there it is. I'm going to make my window like this. Negative 3 to 3 in your x, negative 2 to 3 in your y. So I'm going to click window, negative 3 to 3 in the x, and negative 2 to 3 in the y graph. So here it is. Did yours graph that? Okay. You need to tell your calculator. It's symmetric on the y-axis, so if you wanted to, you could just find one and then put negative on the other. But I'm going to go ahead and call this point A, and I'm going to call this point B. So tell your calculator to find it. Chop, how? What do I push? Second what? Trace, or the calculate button, and which one is it? Number 5, intersect. And then I'm going to say first curve, yes. Second curve, yes. And it says guess, scroll to the one you want. I want this one, and I'm going to call that A. Chop, how are you going to call it A? You'll see right now. Push enter. Do you see how you say it needs to say the word intersection? 1.265. Does yours say the word intersection? Okay, go to the home screen. Chop, how do you do that? Second quit. If you push X, and then I'm going to push the stop button, and then alpha A, look what happens. Push enter, and there it is. That's that same value. Do you guys see what we did? Don't worry, we're going to do another. We're going to do it again. Check it out, Kunduru. Look, we're going to do it again. The next one, the one way over here, I'm going to call that B. Second, calculate number 5 again. And then it says first curve, yes. Second curve, yes. You only have 2 curves. Yes. Scroll to the one you want. I want the one way over here. I'm going to push enter. It needs to say the word intersection. Does yours say the word intersection? Okay. Go back to the home screen. Second quit. So right now it's saved as register X. You don't want to keep it as X, guys. So I'm going to push X. I'm going to push the stop button. And I'll push alpha B. And then push enter. And then look, that's that new one. Cool or not cool? Chop. Okay, fine. I got it in A and B. Why do I want it? Why do I care? Because guys, look, you can just use A and B now. Look, you don't have to do anything. Look, everything's already in Y1 and Y2. Okay, let me warn you guys, when you write this out, do not write Y1, do not write Y2. Okay, guys, focus real quick. So pretend this was the AP exam, or an exam. When you write it out on the exam, you do this. You go integral, and I already forgot. What was this number? Negative 1.2. Give me a whole bunch of digits. 265. 1.265423706. And I'm going to write 2 cosine x minus parenthesis x squared minus 1. I'm not going to bother distributing the negative. Dx. Look at all the parentheses I wrote. You don't have, later on we'll show you how to make it prettier, and it doesn't look as pretty. And then here you go. I'm just going to take my calculator, and I'm going to go second quit. I'm going to go to the home screen. I'm going to go like this. Math 9. I'm not going to put that negative 1.265. I'm just going to put A. Look, it looks nice and clean. For the top, I'm going to put B. See? And then I have, what do I have? I have the 2 cosine x in y1, alpha trace y1, minus alpha trace y2. I go to x, I push x, bam. There it is, guys. 4.9949. Always how many digits? At least? At least 3. Can you write more? Matter of fact, I would like for you to write more. 4.99490 or 91. 4.999490. That's fine. And there it is, guys. We just did it with a calculator. What'd you guys think? Okay, take a 5-minute break. Relax a little bit. There is a delta, but relax.